Hello everyone, welcome back to lecture 13. This is part 2. So, we will continue our discussion on this introduction to flood. So, we started discussing about the hydrograph. So, as you know, the hydrograph can be defined as response of a given catchment to rainfall. So, if we can describe our catchment with respect to rainfall with the help of hydrograph, that means we also need to understand what are the different factors which are affecting this hydrograph, right. So, we have physiographic factors, climatic factors, right. So, here we have basin characteristic, what is the shape, size, slope, nature of the valley, elevation, drainage density. So, that comes under the basin characteristic. When we talk about the storm characteristic, precipitation, intensity, duration, magnitude and movement of storm. Then we have initial loss and evapotranspiration. Then we can talk about the infiltration characteristic, the land use, land cover, how it is playing a role. Then soil type and geological conditions, lakes, swamps and other storage in that particular catchment. Then comes the channel characteristic, whether it is cross section, roughness and storage capacity, whether it is a wide channel or whether it is a narrow channel. What is the duration and the intensity of the rainfall. So, all these we need to accommodate or consider while analyzing this hydrograph. So, this is a typical hydrograph. This is from this particular book. So, here you can see this is discharge in y axis and times in x axis. So, here we have different elements. So, AB, which is from here to here, that is a rising limb. Then C to D, that is your falling limb, and this B to C is the crest, right, and DN, so this DN, that is basically base flow recession, and BC, the point BC, that is inflection points from here, right. So, with the help of this particular hydrograph, we can explain how my catchment is responding to a particular type of rainfall with all these characteristics, right. So, whether it can accommodate more water or less water, what will be the scenario, how the discharge will take place. So, that everything will be explained by this hydrograph. So, effect of catchment shape on hydrograph. The occurrence of the peak and the hydrograph shape is affected by the basin shape. Now, here you can see there are different shapes that has been given, right. So, if this is the shape, this kind of discharge is taking place. Here, when this is the shape, we have more number of tributaries and the shape is different. This is how the time is delayed for this peak discharge. When you have this shape, it is having two peak discharge, right. Here we have one. So, whether it is towards the 0, that means time is very less, that means immediately after the precipitation you will have the discharge. Here in this particular shape, it is delaying the process. So, it is taking more time to show the peak discharge. Here, because of this shape, you have immediate peak discharge, and because of this shape, you have another delayed peak discharge, right. So, effect of catchment shape on hydrograph can be understood through this particular diagram. The hydrograph in catchment A, this one, right, is skewed to the left, right. The peak occurs relatively faster. When we have this B, where the catchment B is skewed to the right. In case of B, the hydrograph is skewed towards the right side, right. So, it is taking more time. So, the peak occurs with a relatively longer lag, or lag is the difference between the first and second event. So, you can consider this time, longer time. The hydrograph in catchment C, it is complex hydrograph, right, due to composite shape. So, here you have this two peak discharge, one at the short period of time, one at the longer duration. When we talk about the size, small catchment will show the immediate response, right. Overland flow is predominant over the channel flow. Thus, the land use and rainfall intensity are crucial in the peak flood. When we have large basin, the channel flow phase is more predominant. When we talk about this slope, large stream slope, quick storage depletion, steeper recession limb of the hydrograph and smaller time base. Smaller catchment, steep catchment slope and large peak discharges, right. So, you can take a piece of paper and with these lines you can draw and you try to understand what is the meaning of these lines. So, then it will be more clear and you will be able to understand what I am trying to convey, right. When we talk about the effect of drainage density on hydrograph, the drainage density is the ratio of the total channel length to the total drainage area, right. So, here you have two conditions, one is A and another is B. So, A is having the high density, B is having the low density, right. Basin with large drainage density, this one, it will be having the quick runoff disposal, right. So, here you can see the peak discharge is coming here. Basin with the small drainage density or low drainage density, the hydrograph is squat with a slowly rising limb. So, that means slowly discharge will take place. It is a better condition compared to this one, right. Then we have land use. For a given storm duration, the surface runoff peak and volume are proportional to the intensity of precipitation. The effect of storm duration is indicated in the rising limb and peak flow, right. So, you just try to understand the hydrograph with these lines. If the storm movement is up the catchment, hydrograph will have lower peak and longer time base. So, if it is, let us say, storm is moving from this to this, right. So, what will happen? Again we will have more time to see the response of this particular rainfall, right. If the storm movement is down the catchment towards the outlet, quicker concentration of flow at the outlet of the basin resulting in peak hydrograph. So, you will have immediate response, right. So, this is 0 and this is the peak, and if it is moving upward, then you will have this kind of hydrograph, right. Then comes the geomorphological effectiveness of flood. By eroding and transporting sediment, floods are essential in forming river channels. Smaller, more frequent floods have a greater cumulative effect than bigger floods, right. Because we are talking about the high discharge and frequently occurring, right. So, they will have major impact than a bigger flood. The most geomorphologically beneficial floods are those that occur moderately and frequently according to Waldman and Miller's model, right. So, you can refer to this model. This is one of the very popular model, especially in humid temperate climate. Channel characteristics like meander, bends and bankful discharge frequently correspond with dominating flows. Bars and bed forms reacts to regular flows, whereas other channel elements adapt to changing flow level. This implies that channel gradually adjusts to a variety of flows rather than a single dominant discharge. So, here you can see the x and y axis, the variable, and here you have magnitude or frequency. This is the discharge frequency, and this one is showing the product of sediment transport rate and frequency, and this is for this one, it is for sediment transport rate, right. So, it shows the relationship between discharge frequency, sediment transport rate and dominant discharge adapted from Woolman and Miller. They proposed it in 1960, right. So, when we talk about the flood plains, how they form, so that you will be able to understand from these figures. So, here you can see we have two A and B. So, the figure shows some of the features which are associated with medium energy non-cohesive meandering flood plains, right. So, here medium energy, right. So, here the flow is having medium energy, right, and the B which is showing low energy cohesive flood plains, low energy you can see, adapted from Nansen and Kroc 1992. So, here you can see different parameter, the Oxbow Lake, meandering scroll bar, this is cut off. So, these figures can help you to understand how the flood plains are formed. So, here the flood plains will be adjacent to this, right. Here you have, these are the flood plains, right. So, this will accommodate the water temporarily when you have the excess water. So, how to define the sinuosity, whether a particular river is straight, sinus or meandering. So, we have a sinuosity index that is very popular. So, here what we do is we take the channel length and the valley length. So, we will try to understand the channel length and the valley length. So, let us consider this is a river system. So, along this main channel, if you consider the length, that will be your channel length, right. And from the start to end, if you take the distance, that is your valley length. Let us see, here we have 400 meter, here you have 600 meter. So, sinuosity ratio will be 600 divided by 400 meters. So, this is 1.5. Now, how to analyze, how to interpret this particular value? So, we have these bases, right. So, if the sinuosity ratio is less than 1.1, that means your channels are straight. If the sinuosity ratio is between 1.1 to 1.5, that means your channels are sinus, right. When you have sinuosity ratio greater than 1.5, that means it is meandering. So, you can see this is almost straight, this is have some sinuosity, then you have meandering nature, right. So, this all can be defined or identified using this sinuosity ratio. It is very popular and it is very useful. When we see the meandering geometry, so here like a wave, you can also define the wavelength here, right. So, wavelength is usually 10 to 14 times channel width. So, that is your W, right. So, here this is the lambda, because we are considering this as a wavelength, and this is the meander amplitude, at what rate or how it is meandering, right. What is the maximum distance which is covered. So, the figure represents the aspects of meander geometry. So, the A, it gives you the wavelength, B, the radius of curvature. The radius of curvature is here. So, you can just try to put a best fitting circle here, that will give you radius of curvature. And the C is typical channel cross section at pool. So, you can see this is a typical cross section, this is from W to X. So, this is this distance, right. Here you have Y to Z. So, this is this cross section, right. So, this will help you to see what is the status of that particular cross section, right. Transformation of a straight channel into a meander, that is also possible, because these fluvial systems are always active, right. So, this is the stage 1, alternating bar dominance, then stage 2 and stage 3 that is formation of riffles and pools. Then stage 4, meandering channel pools are 1.5 times in length, right. Then stage 5, additional riffles and pools form as channels lengthens, right. This figure shows the transformation of a straight channel with a riffle pool bed into a meandering channel, right. So, this particular figure nicely explains how a particular straight channel is becoming a meandering channel, right. So, when we talk about the different types of flood, whether it is natural or man-made or caused by anthropogenic activities, so we can divide this. So, you can see here, so when we are having this natural, we have different causes: landslide, precipitation, tsunami, glacial melt or storm surge. These all come under natural. When we talk about man-made or anthropogenic one, then it is from release from reservoirs or the breach of dam, barrage or embankments, or because of the urban flood, because of the urbanization, right. So, this all are categorized or classified into anthropogenic one, right. And here you have the natural causes. These are some of the examples. You can see the tsunami, how it will cause the flood in this particular region. When we have landslide, this also causes the flood, right. If there is a lake here, then this will be more devastating. Then we have glacial melt. If we have more glacial melt and it cannot be accommodated by our river system, then we will have the flood scenario in the downstream. Because of the high intensity and long duration rainfalls, we have this kind of situation. It is very common. This is the scenario for urban flood, because these floors are impervious, right. So, they are not allowing this water to percolate, and because of that you have more surface water, right. When we have dam breach, so because of the sudden release of the water, you will have this kind of scenario, right. Many people have put their effort in generating the flood risk map. So, this is one of the example. This is the global flood risk map. So, you can see this is for the southern Asia and sub-Saharan Africa, and here you can see how they have given this prediction. So, increase in future between 2010 to 2030. So, this is indicated with this color. Increased in past between 2000 to 2030, it is in the yellow color. Then increasing in past and future, then you have little change or decreasing in past and future, that is with blue. Then we also have a few reasons where we have insufficient data or high uncertainty, right. So, this is from global flood database. You can refer to this particular website. You will find many interesting things, right, related to flood. So, when we talk about the types of flood, we have different types. So, we have river flood, we have flash flood, urban flood and the coastal flood. So, the name itself indicates what kind of flood we are looking at, right. So, when we talk about the river flood, it is related to the river overflow, right. Flash flood, mainly it is because of the sudden release of the water because of some natural or maybe anthropogenic activities. Urban flood, it is because of the urbanization. Coastal flood we can expect in the coastal region, right. So, when we talk about the river flood, it is caused by precipitation over large area or due to snow melting. It occurs in and around the river. So, you can see in both the cases we have river, right, but because of the flood you have excess water here. Here also this is the boundary of this river, right. The ground condition affects the runoff. Now the ground condition, we have already discussed these parameters. What is the soil type, what is the infiltration rate, what is the precipitation, right? How area is having the rock types. So all are playing together here, and then they are resulting in this kind of flooding scenarios. When we talk about the urban flood and ice jam, so urbanization prevents the ground from absorbing rainfall, leading to urban floods. When urban flood strike, streets are inundated resembling rivers, while basement filled completely with water. So you can see it looks like it is a river channel, right? But it is not. It is a lane, right? And it is a urbanized area. So because of this flood, it looks or it appears like a river channel. When we talk about the ice jam occurs when floating ice accumulates in a natural or artificial waterways, obstructing the water's flow. Because of this, if suppose here you put the ice, right, formation of ice, then what will happen? Again you will have more water in these areas, right. So that is the case when we talk about the ice jam. When we talk about coastal flood, so it is because of the tides, storm, tropical cyclones or tsunamis. So you can see how the water is coming into this because of the tides, right. And the storms, tropical cyclones, tsunamis, these are very common, and these are causing the flooding in the adjacent areas. You can see some of the examples here, right. When we talk about this flash flood, so it occurs for a very short time, but contains a great volume of water, right. So here it is very important to note that it is for the short period of time, and it will have great volume of water. It is a life-threatening flood that begins within 3 to 6 hours of the rain event. If you have high intensity rain, then it will occur between this 3 to 6 hours, right. Most flash flooding is caused by slow moving thunderstorms repeatedly moving over the same area, and heavy rains from hurricanes and tropical storms. So again and again your area is receiving more precipitation that will lead to this flash flood. It may result from the failure of dams, that is another case. Several factors contribute to flash flooding. The two key elements are rainfall intensity and duration. As we discussed, if suppose this is the area and the rainfall is or the thunderstorm is moving into this particular region, what will happen? You will be receiving more water, right. So the rainfall intensity, if the intensity is high and the duration is long, you will have this flood flash scenario. A combination of high rainfall rate with rapid and often very efficient runoff is common to most flash flood events. Ice jam formation on rivers can also play a role in rapid onset flash flooding, particularly upstream of the ice jam area, right. So there are three critical soil properties which we consider when we analyze the flash flooding. So first one is soil moisture, soil texture, soil profile, right. Soil moisture is often considered the most important factor for rapid runoff and flash flooding. There is some validity to this reasoning in that if the soil is saturated, there is no room for additional rainfall to infiltrate, right. So if this particular column is already saturated, there is no room for additional water. So what will happen? This will start flowing, and all rainfall become runoff regardless of the soil texture. So if the intensity is high, duration is long, doesn't matter what soil type you have, everything will lead to flood. Flash flooding occurs with high rainfall rates that often exceeds the soil infiltration capacity even when the soil is dry, right. Certain soil textures such as clay and to some extent silt can be associated with low infiltration rates and result in rapid runoff during intense rainfall. Therefore, runoff from intense rainfall is likely to be more rapid and efficient with clay soil than with sand, right. So, this is clay soil with compared to sand will have more problem of the flood. Although sandy soil permits greater infiltration of intense rainfall, rapid runoff can occur if there is only a thin layer of soil. So, the geology of that area is also important. What is the soil? What is the depth of the soil? What is the soil texture? What is the soil profile? That are equally important. So, this is the example of flash flood. You can see these are some of the generated images. So, as we discussed in the beginning, the flood is the most deadly natural disaster, but it has positive impacts also. So, we will see some of the negative and positive impacts. So, when we talk about the flood negative impacts, so communication failure, impact on major road, disrupt transportation, break in power supply, increase in pollution, spread of disease, property loss, loss of lives. These are the negative side of flood. But we also have some of the benefits. Flood water supports life in arid to semi-arid regions. Increase in nutrients, that means it will help you to grow more crops. Increased fish production, more fertile soil, fresh water flood maintains ecosystem in river corridor and the groundwater recharge. These are some of the positive impacts of flood. So, it is also important to note that some of the areas which are dependent on the flood. So, every year they know that we will have the flood, and after flood what benefit they will have, and that they are utilizing, right. So, with this I will end this lecture and we will continue the flood in the next lecture. Thank you very much.